You pick up your phone. You glance at the screen. The tiny padlock icon shivers and drops open. From the moment the screen wakes to the moment that lock clears, less than 0.2 of a second go by. But inside that fraction of a second, your device strips away everything recognizable about you. It reduces your human face into thousands of intersecting coordinates and pure mathematical data. This invisible sequence is the primary mechanism that connects your physical identity to your private digital workspace. Building a digital lock always forces engineers to choose between human convenience and mathematical security. As we see in this image, entering a standard numeric PIN provides strict mathematical security, but typing those identical digits dozens of times a day introduces massive friction into how we actually use our devices. The shift to fingerprint sensors, shown here in this UI prompt, prioritized speed. It worked instantly until a user had wet hands or tried wearing gloves. Early attempts at facial recognition tried to solve this using standard cameras, but looking at this animation, the flaw is obvious. A 2D plane intersecting a face relies on flat distance measuring algorithms. It completely misses the physical depth of the nose, the cheeks, and the jawline. Because of this, a simple, high-resolution photograph could often fool the system. Solving this engineering paradox required a system capable of measuring biological depth in the dark. If we stop the clock right at the start of the process, we can look past the glass and into the hidden hardware array at the top of the display. Instead of a flash, a tiny projector fires 30,000 invisible infrared beams, striking the face. Like a submarine pinging sonar, the beams warp and contour around the physical geography, sinking into the eye sockets and wrapping tightly around the jaw to create a topographical map. Immediately next to the projector, a specialized infrared camera snaps a picture of that highly deformed three-dimensional grid, capturing raw physical depth data. But knowing the exact shape of your face is only the first step. This map must be converted into a language the phone's operating system can actually read. As we move further into the microsecond timeline, that raw grid is routed directly to a dedicated processor called the neural engine. The processor takes that 3D mesh, stripping away its shape, converting the face into a scrolling cryptographic hash. This math instantly enters an isolated hardware vault called the Secure Enclave. The doors lock and the calculation stays buried inside. By keeping the actual math inside that physical vault, the operating system creates a strict firewall. The developers building the apps on your phone are completely walled off and never see your biometric data. Instead, a developer writes a few lines of code that simply knocks on the door of the Secure Enclave and asks a binary question: does the math match the owner? The Enclave simply replies yes or no. This strict architectural division between your physical face and the code asking for verification is what makes the system resilient to outside intrusion. We unfreeze the timeline. The calculation finishes, the final fraction of a second passes, and the lock drops open. This hidden process has removed the need for users to memorize and manage dozens of individual passwords across their apps. When you open a banking platform or transfer money through a crypto wallet, those systems rely on the mathematical difficulty of faking those 30,000 invisible dots. The complex, three-dimensional structure of your physical body has effectively been transformed into your final mathematical signature. Thousands of engineers built a hardware array to map your biology, running it through an isolated neural vault, so you never notice it's happening.